Hello everyone, I am back with the 6th video of the video series on class 9 science motion, and in this video we are going to learn about equations of motion. So they are extremely important. We will talk about the derivation. We will also solve numericals based on equations of motion. So what are we waiting for? Let's start. So we will now talk about a very important topic. We will talk about equations of motion. So what are these equations of motion? Basically, these are a set of 3 equations which relate some of the quantities which describe the motion of an object. So on the basis of whatever we studied so far, what did you observe? What are the quantities that are needed to describe the motion of an object? Well, the quantities are displacement, velocity, initial velocity, final velocity, acceleration, time taken. So these are some of the quantities which altogether can describe the motion of an object. Whether the object is at rest or the object is moving, if the speed of the object increasing with time or the speed of the object is constant. So all such details can be obtained with the help of one or more of these quantities. So equations of motion are a set of 3 equations which establish relationship between displacement, which is denoted by S, time taken denoted by T, initial velocity U, final velocity V, and acceleration A. So these are some of the quantities which are linked to each other by these 3 equations of motion. So what are those 3 equations? They are often known as kinematic equations of motion. Why are they called kinematic? The word kinetic means something in motion, right? So the kinematic equations are, the first equation is V is equal to U plus AT. The second equation is S is equal to UT plus half AT square. And the third equation is V square is equal to U square plus 2AS. So these are the 3 equations of motion. Now these equations are taken, these are the general forms of these equations. For example, suppose if there is a scenario where you have negative acceleration or retardation, in that case your A becomes negative. So the equation will become V is equal to U minus AT, right? So these equations are the general form of equations. And you should remember these 3 equations. Now, these 3 equations together can describe the motion of any object. So now, before we look at the applications of these equations, because their applications are more important, but before that, we will look at the derivation of these equations. So from where did we derive these 3 equations? So let us first try to derive the first equation. So the first equation is pretty simple. So far we know that as per definition of acceleration, what is acceleration? Acceleration is rate of change of velocity, right? That is acceleration. So what does that mean? That means change of velocity with time. So change of velocity is final velocity minus initial velocity upon time. So from this you can see that AT is equal to V minus U, or you can say V is equal to U plus AT. So this equation is nothing but another representation of the definition of acceleration. So we directly derive the first equation of motion from the definition of acceleration. Now let us have a look at the second equation, that is S is equal to UT plus half AT square. So how do we derive this equation? Now in this second equation, we have to basically derive an expression for displacement, because S denotes displacement. Now in order to get displacement, which graph can help us? The area under the velocity time graph gives us displacement. Correct? So let us look at this velocity time graph. So we have taken a generalized velocity time graph. Suppose we have a velocity time graph which is represented this way. Now we have to find out the displacement of this object. We know that the area under the curve is equal to displacement. So what is the area under this curve? So if you join this line, this would be the area under this curve. right? So how do we find this area? Now please forget about these numerical values here. Here we are trying to derive it. So let us say this point is O, this point is B, this point is B, this point is A, and this point is some point C. Let us join this line so we get a point D. So basically we have to find out the area of the triangle BCD plus the area of this rectangle OADB, right? So area under the curve will be equal to area of triangle BCD plus area of rectangle OADB, right? So what would be the area of the triangle BCD? That is half into base into height. So for BCD, what is the base? Base is BD, right? So this would be BD into height. Height is CD, right? Plus area of the rectangle. So this will be length into breadth. That is equal to OA into OB, right? Now by looking at this graph, what do you see? It shows that as time increases, the velocity increases from this point to this point. That means this refers to, this point refers to the initial velocity u, and this point C corresponds to the final velocity v, right? So that means this value is u and this value is v, right? And this value is small t. So that is how we denote things. So we are using the same denotation here to avoid confusion. So in this case, half into BD. What is BD? BD is nothing but t. CD. What is CD? CD is nothing but v minus u. Plus OA. OA is again t into OB. OB is again u. So this is equal to half v minus u into t plus ut. Now if you look at it, v minus u into t, as per definition of acceleration, what is acceleration? It is v minus u by t. So you can write v minus u is equal to at, right? So this v minus u can be written as at into t plus ut. So this is equal to ut plus half at square. And what is this area under the curve? This is displacement. So S becomes equal to ut plus half at square, right? Okay. Now let us look at the third equation, that is v square is equal to u square plus 2as. Now from the second equation, from second kinematic equation, we saw that S is equal to ut plus half at square. But now we need an equation which doesn't have t, an equation excluding t. So what do? In the same equation, we can put the value of t is equal to v minus u divided by a. From where did we get this? We got it from the first equation, that is v is equal to u plus at. So from this equation we can say that t is equal to v minus u by a. So we put this value of t in this equation. So therefore S becomes equal to u into v minus u by a plus half into a into t squared, that is v minus u divided by a whole square. So this becomes equal to uv divided by a minus u square by a plus half a v square plus u square minus 2uv divided by a square. So this becomes equal to uv by a minus u square by a plus half v square by a plus half u square by a minus uv by a. So plus uv by a minus uv by a will get cancelled. So we are left with minus u square by a plus half u square by a, that is minus half u square by a plus half v square by a. So this is equal to s. So from this we can say 2as is equal to v square minus u square. So from this we can say v square is equal to u square plus 2as. Here we arrive to the third equation of motion. So these are the three equations of motion, and now we will see that using these three equations of motion, we will be able to solve so many problems. So let us look at problem 1. It states, a bus starting from rest moves with a uniform acceleration of 0.1 meter per second square for 2 minutes. So that means the acceleration of the bus. Okay, the bus starts from rest, so initial velocity would be 0. Acceleration is 0.1 meter per second square, and it attains this acceleration for 2 minutes. So time taken is 2 minutes. So that is 1 minute is 60 seconds. So therefore, this would be 2 into 60, that is 120 seconds. So we have to calculate in the first part speed acquired, that is we have to calculate v. So from the first kinematic equation, v is equal to u plus at, so that is equal to 0 plus 0.1 into 120. So this comes out to be 12 meter per second. So this is the speed acquired. In the second part, it asks us to calculate the distance traveled, that is s. So from the second equation, we can say s is equal to ut plus half at square. So this will be equal to, so now in this case, u is 0, so this comes out to be 0 plus half into a is 0.1 into t square, that is 120 into 120. So this will be 60, and this comes out to be 720 meters. So 720 meters is the distance traveled by the bus. Let's look at problem 2. It says a train is traveling at a speed of 90 kilometers per hour. Okay, brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. So we are applying brakes to decrease the speed. Find how far the train will go before it is brought to rest. So that means in this case, initial velocity is 90 kilometers per hour. So if we want to change it into meter per second, it will become 90 into 1000 divided by 60 into 60. So this comes out to be 25 meter per second, right? Now in this case, we have to find out the distance till which the train will go before it comes to rest. That means finally it has to come to rest. So its final velocity should be equal to 0. What is the acceleration? Acceleration is minus 0.5 meter per second square. So it is basically retarding, right? We have to calculate the value of s. Now from the third kinematic equation, we know that v square is equal to u square plus 2as. So s becomes equal to v square minus u square divided by 2a, right? So v is 0, so this becomes minus u square by 2a. This is equal to minus 25 square divided by 2 into minus 0.5. So this minus and this minus will get cancelled. So we get it as 625 meters. So this train will travel a distance of 625 meters, and after that it will come to rest. Let's have a look at problem 3. It says a trolley while going down an inclined plane has an acceleration of 2 centimeter per second square. What will be its velocity 3 seconds after the start? So in this case, the acceleration of the trolley is given as 2 centimeter per second square. So if we convert it into meter per second square, it will be 0.02 meter per second square. So what will be the velocity 3 seconds after the start? So that means we have to calculate the velocity after 3 seconds. So time will be equal to 3 seconds after the start. That means the trolley had just started moving. So its initial velocity is 0. So we have to calculate the final velocity. So you have v, u, a and t. So which equation would be appropriate for this? The first equation, because it connects all of them. V is equal to u plus at. So u is 0 plus a is 0.02 into 3. So this is equal to 0.06 meter per second. Or this can be written as 6 centimeter per second. So this would be the velocity after 3 seconds from the start. Here comes problem 4. It says that a racing car has a uniform acceleration of 4 meter per second square. Okay, so the acceleration is 4 meter per second square. What distance will it cover in 10 seconds after the start? So here also it is starting, so u will be equal to 0. Time is equal to 10 seconds. So we have to calculate the distance covered, that is s. So in this case, which would be the appropriate equation? The second equation, because it connects u, a, t and s. So this will be s is equal to ut plus half at square. Now u is equal to 0. So it becomes half at square, that is equal to half into a into t square. So this comes out to be 200 meters. Let's look at the next problem. A stone is thrown in a vertically upward direction with a velocity of 5 meters per second. So it says that if the acceleration of the stone during its motion is 10 meters per second square in the downward direction, what will be the height attained by the stone and how much time will it take to reach there? Okay, so in this case, what's happening? There is a stone which is thrown upward. So first when the stone is thrown upward, it reaches a maximum height and then falls back towards the ground. So what happens in this case? Initially, the velocity with which it is thrown is 5 meters per second, right? What will happen when the stone is thrown upward? It will reach to the maximum point. So the point where it reached, from where it will revert back and it will start falling back. At that point, that means at that maximum height, the velocity would be 0. Because when it reaches the maximum point, it becomes stationary for a while. So at that maximum height, velocity v is equal to 0. So this refers to the maximum height, right? And what is the acceleration? Acceleration is 10 meters per second square. Now since the stone is moving in the upward direction, but the acceleration due to gravity is in the downward direction, therefore this acceleration would be negative. Now let us suppose that the maximum height is denoted by s. So now using the first equation, we can say v is equal to u plus at. So from this, we can say v is equal to u plus a is minus 10 into t. So from this, we find that t is equal to 0.5 seconds. So that means this is the time taken for the stone to reach the maximum height. Now we have to calculate the maximum height h and also the time it will take to reach there. So we have already calculated the time taken to reach there, time taken to reach the maximum height. Now we have to calculate s. Now let us make use of the third equation, that is v square is equal to u square plus 2as. So this will be equal to 0 square is equal to u square, that is 5 square plus 2 into a is minus 10 into s. So from this we can say 0 is equal to 25 minus 20s, or s is equal to 25 by 20, that is equal to 1.25 meters. So this is the maximum height that the stone will reach, and this much amount of time it will take to reach the maximum height. Let's look at problem 6. A motorboat starting from rest on a lake accelerates in a straight line at a constant rate of 3 meters per second square for 8 seconds. So how far does the boat travel during this time? So that means there is a motorboat which starts from rest. So initial velocity is equal to 0. Acceleration is constant, which is 3 meters per second square, and for how much time it travels? It travels for 8 seconds. So how far does the boat travel during this time? So we have to calculate s. So looking at the values which we need and which we have, second equation would be the best option. So S is equal to ut plus half at square, that is equal to 0 plus half into a into t square, that is 8 into 8. So this will be 4. So this comes out to be 96 meters. So this much distance the boat will travel during this time. Let's look at the last problem of this section. It says a ball is gently dropped from a height of 20 meters. If the velocity increases uniformly at the rate of 10 meter per second square. So increase rate at which the velocity changes is nothing but acceleration. So height, that is S, is given as 20 meters. Acceleration is given as 10 meter per second square. With what velocity will it strike the ground? V has to be found out. And the stone is dropped from a height. So that means when it was dropped initially, initial velocity was 0. Right? So let's make use of the third equation, which is V square is equal to U square plus 2AS. So from this we can say 0 plus 2 into A into S. So that is equal to 400. So from this we see V is equal to 20 meter per second. Now next part, after what time will it strike the ground? So we have to find out the time. So in order to find out the time, we'll make use of the first equation, which is V is equal to U plus AT. So T becomes equal to V minus 2 by A, that is equal to 20 minus 0 divided by 10. So this is equal to 2 seconds. So after 2 seconds, the ball will strike the ground.
I hope you enjoyed the video, and in the next video, we are going to learn about uniform circular motion. Stay tuned.